So here we have 2016, this is question 4a, and we're given the function here, and we're asked to find the coordinates where it cuts the y-axis. So say if we have a graph and it cuts the y-axis, well, so that would be, say, for this graph, it would be this point here. But anywhere along the y-axis, something is on the y-axis, the x-coordinate will be 0. So to get where it crosses the y-axis, we have to let x equal 0. So let x equal 0. So we have to get, so when we let x equal 0, it would be f of 0 is 0 cubed plus 0 squared minus 2 by 0 plus 7. And we get out, so that's just 7 is left. So then the coordinates will be 0, 7. And then the next part, we are asked to verify using algebra that the point A, 1, 7 is on the graph. So if we want to show that a point is on the graph, we have to sub in the values of x and the values of y, and it should work out. So I'm going to sub in x is equal to 1 plus 1 squared minus 2 by 1 plus 7, and then we have to let that equal to the y value, which is 7, and see is it true. So 1 plus 1 gives me 2, minus 2 plus 7 is equal to 7. So 2 take 2 is just going to be 0, so that's going to be 7 is equal to 7. So that's true, so that's on our graph. And then we are asked to find, going to in this case, and we're asked to find f of x, which is the derivative. So our equation is f x is equal to x cubed plus x squared minus 2x plus 7. So just a quick note on derivatives. Say if we had something like 2x squared, the rule I would go with is the base, which is this, by the power, which is this one. So this is the base, this is the power. So I would go base by the power. So the base, which is 2x, by the power. So that would be 2 by 2x, which will be 4x. And the power minus 1, so that'll be x to the power of 1, or just 4x. Say if we had something like, if our function was 2x, well, we use the same rule, base by the power. So the power here is 1, so 1 by 2 just gives us 2. But then the power minus 1, so that goes to x to the power of 0. But anything to the power of 0 is 1. So if we have something like 2x, that just arrives to 2. But if we had something like f of x is equal to 4, the slope of that just arrives to 0. So the derivative of that, because there's no x, will just be 0. So if we had something like f of x is equal to 2x squared plus 4x plus 6, so the base, which is 2x, by the power, which is 2, so that'll be 4x. And then, so this will just go to 4, and that'll be the derivative. This will be the derivative of that. So if we're to get that for this, so the power is 3, so the base by the power, so will be 3x squared plus 2x minus 2. So that's going to be the derivative. And then we're asked to, so the derivative is also, we can also call that the rate of change. So derivative is equal to rate of change is equal to the slope of the tangent to the graph. Tangent. So say if we have a function here, so the tangent is going to be a straight line that cuts it at just one point, touches it at just one point, and it's going to give the slope of the graph at that point. So the tangent is just what I've drawn in red. So the tangent is going to be just a straight line. So we're asked to, so we got the derivative, and then we want to get the slope of the tangent. So the derivative also gives the slope of the tangent, so we just have to plug in x is equal to 1 into the slope of the tangent, into the derivative function. So this here is the derivative function. So 3, 1 squared plus 2 by 1 take 2. So that's going to be 3 plus 2 take 2, so that's going to be just equal to 3. So the slope of the tangent, so the slope is equal to 3. And then we're asked, hence find the equation of the tangent. So we know that the tangent is going to be a straight line. So if we want to get the equation ever of a straight line, we use the formula from our log tables. Y minus y1 is equal to mx minus x1. We can use the y equals mx plus c if we know where it cuts the y-axis, but in this case we don't. So we're going to have to use the formula y minus y1 is equal to mx minus x1. So in this case, so to use this, we need a point on the line. So we need a point and we need a slope. So in part B, we verified that the point 1, 7 is on the graph, and they're asking us to get the tangent at the point 1, 7. So we already verified in part B. So 1, 7 is on the graph, and we want to get the slope of the tangent at 1, 7. So we already got the slope of the tangent when x equals 1. So the slope of this tangent, so the slope is going to be 3, because that's the slope of the tangent when x equals 1. So we got the slope was 3 in the last question. And a point on the, so we have a point, so we're given a point, so it's 1, 7. So if we want to get the slope of the tangent at 1, if we want to get the equation of the tangent, we're going to have to sub in. So our point is going to be 1, 7. So we can call that x1, y1. Our slope is going to be 3, and they call that m. So it'll be y minus y1, which is 7, is equal to m, which is 3, x minus x1, which is 1. So y minus 7 is equal to 3x minus 3. So I might just get everything on the same side. So 3x minus 3 plus 7, and then minus y equals 0. So that will be 3x minus y plus 4 is equal to 0. So that is the equation of the tangent to at the point 1, 7.